Hey everyone, today I'm going to show you how we can implement web scraping in NestJS using Puppeteer. So in this project, we're going to scrape Amazon to get a list of information about any products we want based off of a search query. So you can see here, I've searched for pillows, and for each product, we're going to get a URL, a title of the product, and the price. So this is scraped directly from Amazon, and we can even change the product query to whatever we want to get a response back and get real-time information about really anything on the internet that we want to scrape. We can do it easily with NestJS and Puppeteer. So you can see here, I've just got a result set back for all of these different laptops. And with the patterns we'll learn in this video, we can scrape anything we want on the web as long as it's publicly available, which can be extremely useful in building any sort of application we want. So let's jump right in, and I'll see you in the video. Okay, so to get started, we're going to use the Nest CLI to initialize our project. So as always, if you don't have the Nest CLI, or you want to make sure you're running the latest version of it, you can do this by running sudo npm install -g at nestjs/cli at latest to get the latest version, and enter your password and let the installation go ahead and complete. So we'll initialize a new project by running nest new, and I'll call this NestJS scraping. And for our package manager, I'll go ahead and use pnpm. So we can go ahead and now cd into our project directory, and I'll go ahead and open up this in VS Code. Now, as always, I'm going to keep the completed code for this project in a GitHub repository, and I'll leave a link to that repository in the description so you can follow along and check out the completed project there. Okay, so we have the default Nest project out of the box with our main.ts file, with our bootstrap function that will bootstrap our application and listen for incoming HTTP traffic on port 3000 by default. So as always, we have our one app.controller controller with one get route, which is simply going to be returning a hello world string from our app service. Now we can go back to our terminal window and run pnpm run start dev to make sure our application starts up properly. So you can see our Nest app has successfully started. And then I'll go ahead and open up Postman. So I've gone ahead and opened up Postman so we can launch a test request at our server. So let's launch a request at localhost 3000 where our server is running, and the root path will launch a get request. We can see we have a hello world response returned from our one get route in our app controller. So let's go ahead and remove these app.controller files that we will not be using, as well as the app service, since we're not going to be using this. Then in the app module, I'll go ahead and remove the references to these files as we're no longer using them. And then I'll open up a terminal window in VS Code so that we can use the Nest CLI to generate a new module for us. So we're going to generate a module called Amazon. This will be the module responsible for having all of our Amazon scraping code. And you can see the Nest CLI has created an Amazon module for us and added it to our imports array in our app module. So nothing is in the Amazon module currently. Let's go ahead and use the CLI to generate a controller called Amazon as well. And by default, this will add to the Amazon folder and also add it to our Amazon module. And then we'll go ahead and do this one last time to generate a service called Amazon as well. So we have a controller, module, and service. So you can see the controller has been added to our controllers array, and the Amazon service has been added to our providers array. So let's go ahead and add our first route in here so that we can actually expose HTTP traffic. So I want to add a get route. We'll do this by calling @get and make sure we import this decorator from NestJS common. And then we can prefix this with products so that The URL will be /Amazon/products. And then we'll call this function getProducts, which will reach out to the Amazon service. So to get access to this, let's have a constructor where we inject it. So we'll have a private read-only Amazon service of type Amazon service. So next up, I want to actually extract a query parameter from this route that we will use to input into the Amazon product search field so that we can actually search for products and make this dynamic. So to extract a query parameter, we'll use the @query decorator from NestJS common. And then I'll call this query product so that we can extract this specific query, and we'll go ahead and call this product of type string. So now that we have this product query, I want to return this .amazonservice.getProducts and pass in the product string. Now, of course, this doesn't exist yet, so we'll go into our Amazon service and now add the async getProducts method that takes in the products string. And now we can actually implement this getProducts method. Okay, so we're ready to start actually writing code to scrape Amazon. So to get started, let's go ahead and install Puppeteer. So Puppeteer is going to be the library we're going to use to get access to a high-level API that's going to let us to control a Chrome browser over the DevTools protocol. It's going to run in a headless mode, and we can use it to actually go to a web page, scrape HTML, navigate around, click buttons, and do anything as if we were on a web page. So let's go ahead and npm install save Puppeteer core. So now that we have Puppeteer installed, we need a way for it to actually connect to a remote browser. Now, we could use a browser locally, and that would be fine. However, the issue we're going to run into when scraping data at scale is that most large websites have mechanisms in place that will prevent automatic scrapers from accessing their websites. So they can use tools to detect when a scraper is scraping their data and block your IP address. So we want a tool that will allow us to connect to a remote browser session without getting blocked because we're scraping data. And that's where Bright Data comes in, which is also today's video sponsor. It's a great solution to actually implement scraping, because what it's going to allow us to do is it's going to allow us to connect to their remote browser, which runs through a proxy network, which means the actual scraping that happens is going to be happening through their proxy network. The actual IP address is always going to be different, so we're never going to get blocked when we scrape external websites. So this tool is extremely useful when we're trying to scrape large websites at scale. And the best part is they've given me a $10 credit to their services so that you can follow along with this tutorial at no cost. Simply click on the link in the description, set up an account, and head to your dashboard where you can see we have this proxies and scraping infrastructure tab. And here we can click on the add button and add a scraping browser. So you can see here, it's an all-in-one browser that will allow us to scrape any website at scale without being blocked, which is exactly what we want to do. So after you've gone ahead and created your scraping browser integration, go ahead and click on it, and then you can click on the checkout code and integration examples, where if we scroll down, you can get access to this SBRWS endpoint. So this endpoint is going to be what we're going to provide to Puppeteer to actually connect to a remote session. So go ahead and copy this string that we'll use to connect Puppeteer to their proxy network. I'll go ahead and copy this. And then what I want to do is go back to our project, and then I want to create a .m file where we can paste in this sensitive data. So go ahead and create a new SBR/WS endpoint environment variable and scrape in that string without quotes. So I'll paste in the entire string here, which is what we're going to be passing in to Puppeteer to connect to our remote browser through the Bright Data proxy network and make sure we won't get blocked when we scrape data. So in order to actually inject the environment variable into our application, we're going to make use of the NestJS config module. So simply npm install --save nestjs/config to install the config dependency. And now let's go back to our app.module so we can actually set up our config module. So in our app.module, in our imports array, we'll go ahead and add a new import. So we'll have a config module .for root, and we're going to go ahead and set is global to true so that we make the config module globally available. And now next up, we can go directly to our Amazon service. And let's go ahead and inject the config service into our constructor so that we can use it. So we get access to a config service, and this is from NestJS config. And now we can use the config service to get that M variable that we just provided. So I'll also make sure I go ahead and start up our server back up. Now let's go ahead and start implementing our getProducts method. So the first thing we're going to do is create a new const called browser and connect Puppeteer to our remote browser session through the Bright Data proxy network. So let's call await Puppeteer, and we need to make sure we import Puppeteer. So let's import Puppeteer from Puppeteer core. So now we'll await Puppeteer .connect, and now we provide an options object where we specify the browser WS endpoint. So this is going to be the remote browser endpoint that we have in our .m file that will allow us to connect to the Bright Data proxy network. So let's call this .config service .get or throw, and now extract that SBR WS endpoint. So now we have a browser that's connected to this remote browser, and it'll be run anywhere in the world to prevent us from getting blocked from scraping any website, because to the website we will just be a normal end user whose IP address will always end up being different. So now that we have the browser, let's go ahead and open up a try finally block, because no matter what code we now execute, we want to make sure that we always call await browser.close when we finish to close the browser session. So now let's go ahead and get access to a browser page by setting a new const equal to await browser.page new page, and now we have a page object. So the first thing I want to do is set a timeout on the page so that if we have any issues navigating, our code won't run forever. So let's set a default navigation timeout, which is the timeout in milliseconds. So I'll do 2 times 60 times 1,000. And now we're going to go ahead and tell the browser to actually navigate to Amazon. So let's go ahead and await promise.all, because we want to await two promises. So the first is going to be a call to page.wait for navigation, which is going to tell the code to actually wait until our navigation finishes. We'll call page.go_to, and now we supply the URL. So in our case, we'll go to https:/amazon.com to navigate to Amazon. So to make things a bit easier, I'll also navigate to Amazon in my browser and open up the dev tools, because we're going to be utilizing the different selectors in the HTML to actually scrape the data appropriately. And since these classes and IDs could potentially change in the future, you should follow along with me and see how I'm doing it so that you can always come back and change your code as necessary. So the first thing we want to do on this page is target the search bar here and actually click on it, type in the query from our API call, and then click on the search button to actually navigate to a product page. So to run through this completely, we want to click on it and then import the product query from our API call. So we'll say laptop, and then click on the search button so that we're brought to the actual product listing page where we can scrape data. So to do this, let's take a look at the HTML for this search bar. Now in particular, the input is what we want to target here. So we can see it has an ID of 2 tabs search text box. So let's go ahead and target this ID. I'll go ahead and copy the ID. And now we can go back to our code and actually target this text box and type a query into it by calling await page.type. And now we'll enter the selector in that we just copied. So make sure we use the hash sign to target the ID. And then we'll give it the value we want to type into the box, which in our case is the actual products query that's passed in as an argument to the method here. So now at this point, we've typed our query into the search box, and now we want to click on the submit button. So we'll go back to the HTML here and look at a selector for the button. And in this case, we have an ID here of nav search submit button. So let's copy this and go back to our code and call await promise.all, where we'll follow a very similar pattern as we did for the first navigation. We will call page.wait for navigation so that we wait for the page to finish navigating before continuing our code. And then finally, to actually execute the click, we'll call page.click and enter in our selector, which is the submit button. So now at this point, we have our query typed into the search bar and we've clicked on the search button. So we should have been brought to this product listing page. So now at this point, we want to be able to target this list of products and scrape the individual details from each one and formulate a response to our end user. So for example, let's say we want to grab the title of each product, the price of each product, and the URL of each product. Let's see how we can do that next. So the first thing we need to do is get access to a selector that will give us access to an individual result. So to do that, let's hover over each of these elements until we find a container element for all of the results that we want. So this looks like a good one. It'll be the div that contains all of our search results. So let's include this first class, sSearchResults, as our container. So now in our code, we're going to return await, and now we're going to call page.$eval. So if we look at the description, what eval is going to do is it's going to run array.from document.query selector, the selector we pass in within the page, and pass the results as the first argument to the page function, which is going to be the callback. It's going to allow us to execute JavaScript directly on the selector that we provide here. So let's go ahead and fill this out so it'll be a bit more clear. So we want to firstly provide the selector of the individual element that we want to be targeting. We'll start off with the s.searchResults class that we grabbed earlier. And now we need a selector that will target an individual product. So if we keep scrolling down a bit more until we find this div here, we can find another div that will have the class that we want. So you can see here, I'm hovering over and we have this product entry. So this is the div we'll want to select because it contains all of the information we want with inside of it, the title, price, and URL. So to target it, we'll use this sCardContainer class. So we can simply copy this class And now back in our code, we will paste this additional selector in to target the individual product. Okay, so now the second argument that this will take is the callback function that will get the result items, which will be each individual product. We can map over them and extract the data we want from within each one. So to do this, let's go ahead and return result items.map, and then we'll get access to a single result item. And now within this function, this will be the individual product, okay? And so now we need to actually extract the URL, title, and price from that given product. So to start off with the URL, that's going to be the easiest. What we can do is, if we look again at the HTML, really what we want to be looking for is the first link element that we find and get the href, because that'll lead us to the product link. So we can do that very easily by creating a new const called URL, and we'll set it equal to result item. And now, like I said before, this is going to be as if it's a DOM element, so we can execute JavaScript directly on it. So we'll call result item dot query selector, and within this, we'll select the first link or anchor tag that we find and extract the href. So now we have access to the URL. Let's go ahead and find the title. So inside of this anchor tag, we can see we have a span here. So to target this span directly, we'll go up and target this class called sTitleInstructionStyle, because this will be specific to the title. So I'll copy this class sTitleInstructionStyle, and then we want to select the first span element that we find within. So by doing this, we can select the actual text itself. So let's go ahead and do that. We will get the title by calling result item.query selector and paste in the class that we just copied. And then we want to get the first descended span element. So now we have the span. We'll grab the text by calling question mark to see if it exists .text content. So you can notice there's a lot of different ways to go about doing this. You can choose the different selectors you want that will get you to the end result. Sometimes you have to be a little bit creative in scraping this data, and there's definitely more than one way to get access to the data. So finally, we want to get access to the price. So let's go ahead and inspect the price element. And if we take a look, we can actually see we have this nice span here called A off screen, which will give us the total price. So to target this, let's target the A price class and then target the A off screen span. So we get access to the price with the currency. So the price will be equal to result item dot query selector, and we want to scrape the A price class and then the A off screen class. And now that we have this, we'll target the text content to get the text content. So now we have these three elements that we want to return back to the user. And of course, you could keep going with this and scrape any amount of data that you needed for your solution. However, for us, we'll go ahead and simply return an object now. So whatever we return from this eval function will get sent back to the outer scope. So we return the URL, title, and price inside of this object. So you can see our Nest application is still running successfully, and now we're ready to actually give this a try. So let's launch a GET request, a localhost 3000/Amazon/products, and then I'll set our product query equal to, well, this will be whatever product we actually want to search for. So let's start off with the laptop query that we just worked on. So I'll go ahead and send off this request. And what this is going to do is it's going to launch a Puppeteer browser session using the remote browser that we specified using Bright Data. So this is actually going to launch a browser remotely, and we can see we get data back. We're not being blocked, and we can launch this request any number of times we want, and it will continue to not be blocked thanks to the Bright Data proxy network. And so we can see we get this really nice list back of all of these products. And within each one, we get a nice URL, the title of the product, and the price. So we get all of this information thanks to our scraping. And we can go ahead and show how this works really dynamically by changing the query now. So we were just looking for laptops. Let's say we want to find a new pillow. So I'll search for a pillow now. And again, this is going to launch a new browser session through the proxy network using a different IP address so that to Amazon, it looks like it's coming from a totally different user. And we get all of this data from Amazon, including all of these different products, the URL, the price for each one. So we could even click on any one of these URLs and we get brought to the product that we can see here. So you can really see how versatile this Puppeteer and Bright Data combination is. Using them together, we can really scrape any data we want all over the web without having to worry about getting blocked. I hope you learned a little bit on how scraping can be really easy with NestJS and Puppeteer, and I'll see you in the next one. Thanks.